Do you believe in multiverse? Our observable universe is a titan holding 2 trillion galaxies stretching 93 billion light-years across the infinite dark. It feels like the ultimate limit of existence. But is this wall of light truly the end of everything? Some of the most brilliant minds in physics say no. They have traced the logic of the atom to its absolute breaking point, uncovering a disturbing conclusion: our reality may be just one bubble in a boiling ocean of trillions. The math has spoken, and it screams that we are not alone. But where is the undeniable evidence to hunt for the smoking gun? We must first peel back the layers of time to the violent mystery of our own beginning. Because to understand why we might be living in a multiverse, we first have to understand why we exist at all. For decades, cosmologists were haunted by a specific mystery known as the horizon problem. When we look at the universe in opposite directions, left and right, up and down, we see regions that are separated by billions of light years. These regions have never touched. Light has not had enough time since the Big Bang to travel between them. Yet impossibly, they are the exact same temperature. It is as if two strangers on opposite sides of the planet who have never met or spoken showed up to a party wearing the exact same clothes, down to the stitching. In the 1980s, physicist Alan Guth proposed a radical solution called cosmic inflation. He suggested that in the tiniest fraction of a second after its birth, 1035 seconds to be precise, the universe didn't just expand. It exploded outward at a rate faster than light, smoothing out all irregularities. This theory worked. It explained the uniformity of the cosmos perfectly. But when physicists like Andre Linde looked closer at the math, they found a terrifying consequence hidden inside the equations. Inflation is not a one-time event. It is a state of being. Imagine a vast, infinite ocean of energy boiling violently. This is the inflaton field, a primordial state of high energy that permeates existence. In this boiling ocean, quantum fluctuations constantly trigger phase transitions. Just as bubbles form in a pot of boiling water, regions of this field spontaneously cool down, dump their energy, and stop expanding. Inside one of those cooling bubbles, the energy converts into matter and radiation. Stars ignite, galaxies spin, life evolves. We call that event the Big Bang. But the Big Bang was not the beginning of everything. It was merely the moment our specific bubble stopped boiling. Here lies the existential vertigo: the ocean outside our bubble never stops boiling. This is the theory of eternal inflation. While we drift in our calm, cool pocket of reality, the high-energy field around us continues to expand exponentially, spawning new bubbles every fraction of a second. Some might have different laws of physics. Some might collapse instantly. Others might be vast, empty voids. We are drifting in a cosmic Swiss cheese, where the holes are entire universes. If this theory is correct, our universe is not a unique masterpiece. It is merely one droplet in a frothing, infinite sea of creation. But theories, no matter how elegant, are just stories written in math until we find physical evidence. We cannot step outside our bubble to see the ocean. We are trapped inside. So to prove the multiverse exists, we must look for a sign that something from the outside has touched us. We need to examine the edge of our observable reality for a fingerprint. The boundaries of our universe are defined by primordial light, the fossilized memory of the Big Bang's heat. We call it the cosmic microwave background, or the CMB. This is the oldest light in the cosmos, released 380,000 years after the Big Bang, when the universe finally cooled enough to become transparent. Today, telescopes like the Planck satellite have mapped this light in exquisite detail, creating a baby picture of our reality. To a forensic cosmologist, the CMB is the ultimate crime scene. According to the standard model of cosmology, this map should be relatively smooth. The temperature variations, the red hot spots and blue cold spots representing density fluctuations, should be random and scattered evenly like static on an old television. And for the most part, they are. But when scientists analyzed the southern hemisphere of this cosmic map, they found something that stopped their hearts. There is a spot that is too cold. Known as the CMB cold spot, it is a massive region roughly tarnor across the sky that is significantly colder, about 70 to 150 microkelvin lower than the average surroundings. Standard physics struggles to explain it. Some dismissed it as a statistical fluke, a random error in the data. Others tried to explain it away as a supervoid, a giant region of empty space lacking galaxies known as the Eridanus supervoid. But even the largest void models fail to account for the sheer depth of the temperature drop. Then a more chilling hypothesis emerged. If we live in a crowded multiverse hotel and the bubbles are constantly expanding, is it possible that two bubbles could bump into each other? Dr. Laura Mersini-Houghton, a theoretical physicist, proposed that the cold spot is not an error. It is a cosmic bruise. Imagine two giant soap bubbles floating in the air. When they touch, they don't always merge. Sometimes they press against each other, flattening the contact surface before bouncing apart. If a neighboring universe collided with ours early in our history, the impact would have pushed matter away from the collision site, leaving behind a permanent scar, a region of lower density and temperature, where tasks are imprinted on the edge of the sky. The cold spot fits the profile of such a collision. And it is not the only anomaly. Scientists have also identified the axis of evil, a strange alignment of temperature fluctuations that shouldn't exist in a random universe. These are the fingerprints on the glass of reality. They suggest that our locked room has been battered from the outside. We are staring at a crime scene where the victim our universe shows signs of a struggle. The bruise in the southern sky whispers a terrifying truth: we are not floating alone in the void. We are bumping shoulders with giants in the dark. But if the macroscale evidence suggests we are just one bubble among many, the evidence at the microscale, the world of atoms and particles, suggests something even stranger. The multiverse might not just be outside us, billions of light years away. It might be happening right here inside every decision we make. If the evidence for the multiverse on the cosmic scale is a bruise, the evidence on the atomic scale is a shadow. To find it, we must zoom in from the edge of the universe to the very atoms that make up your body. For a century, physicists have tried to ignore the unsettling paradox hiding in the equations of quantum mechanics. We are taught that atoms, the building blocks of reality, exist in a state of superposition. An electron is not a hard ball at a specific coordinate. It is a quantum cloud, a wave of probability existing in multiple places at once. It is here, there, and everywhere, in between, all simultaneously. But the standard story tells us that the moment we look, the moment we measure it, the superposition vanishes. The wave collapses. The electron snaps into one single position, and all the other possibilities fade away. This is the standard simplification we use to make sense of the world. We tell ourselves that reality is singular. But in 1957, a brilliant doctoral student named Hugh Everett III looked at the math and asked a dangerous question. What if the wave never collapses? Everett argued that the act of observation doesn't destroy the other possibilities. It merely separates them. When you measure an electron, you don't force it to choose a location. Instead, you force the universe to split. In one branch of reality, you see the electron on the left. In another branch, an identical copy of you sees it on the right. Both versions of you are equally real. Both believe they are the only one. This is the many worlds interpretation, and it relies on a mechanism called decoherence. Think of the universe not as a single timeline, but as a rapidly growing tree. Every time a subatomic particle interacts with another, every time a photon hits a leaf or a neuron fires in your brain, the trunk splits. The branches grow apart, becoming orthogonal, meaning they can no longer interact or communicate. The other branches are right here, millimeters away in the Hilbert space of quantum mechanics, but we can never touch them. We are walking through a crowded room of invisible realities, completely blind to them. But if this theory is just dry mathematics to you, consider the most terrifying implication. If every physical possibility must happen, then death is not what you think it is. Let's conduct a thought experiment. Not about death, but about the continuity of awareness. Imagine you are in a quiet room with a device connected to a quantum trigger, perhaps the spin of a single quark. If the quark spins down, the experiment ends for you instantly. Your conscious experience simply ceases like a dreamless sleep that never breaks. If it spins up, the device emits a pleasant chime, and you continue to sit there fully awake. The odds are 50-50. You press the button. According to the many worlds interpretation, the universe doesn't choose one outcome. it accommodates both. The reality splits. In branch A, the cork spins down. Your timeline ends. There is no pain, no darkness, just an abrupt lack of being. For the outside world, you are gone, but you are not there to experience that ending. In branch B, the cork spins up. You hear the chime. You blink. You are still here. It was just a coin flip, you think. You press the button again. The reality splits again. In one branch, silence. In the other, you hear the chime. You press it 10 times, 100 times. In billions of parallel branches, your journey is ended. But to your consciousness, the only lens through which you can perceive reality, the silence never comes. You hear the chime again and again, defying all statistical probability. This leads to a profound and unsettling realization, known as subjective continuity. From the outside perspective, you are mortal, fragile, and statistically lucky. But from the inside, you are tethered to the only timeline that supports your existence. This implies that no matter how improbable the survival a near miss on the highway, a recovery from a fatal diagnosis, your consciousness will naturally flow into the branch where you endure simply because it cannot experience the branch where you do not. We are not trapped in a prison, but perhaps we are walking a solitary path. As the timelines diverge, we are constantly surfing on the edge of the wave that keeps us existing, leaving the other possibilities behind in the dark. It suggests that we are not just separated by distance, but by the very path of our destiny. And yet even this quantum solitude is small compared to the chaos lurking in the very structure of space itself. If the quantum world suggests that reality is a haze of probabilities, string theory suggests we are crawling on a thin sheet of paper, oblivious to the vast structure built around us. This theory emerges not from a clue, but from a glaring contradiction at the very heart of physics, the hierarchy problem. Pick up a paperclip with a small refrigerator magnet. Think about what just happened. That tiny magnet, no bigger than a coin, just defeated the gravitational pull of the entire Earth. The gravity produced by a planet of 6 septillion kilograms was overpowered by a piece of magnetized iron. Why gravity is suspiciously weak. In fact, it is 1032 times weaker than the electromagnetic force. In the world of physics, numbers like that don't happen by accident. A discrepancy that massive suggests we are missing a huge part of the picture. String theory offers a solution, but it requires a sacrifice. We must give up the idea that reality has only 3 dimensions. To make the math work, the universe must have at least 10, perhaps 11 dimensions. We live in 3 spatial dimensions plus time, but the others are tightly curled up, hidden at scales smaller than a proton. Imagine our entire universe as a 2D sheet of paper floating in a 3D room. We are flatlanders, stuck on the paper, unable to see or move into the room which physicists call the bulk. The forces that govern our lives, electromagnetism, the nuclear forces, light itself, are open strings. Their ends are stuck to the paper. They cannot leave our universe. That is why we cannot see into the other dimensions. Light is trapped here with us. But gravity is different. According to M-theory, the graviton, the particle that carries gravity, is a closed string. It has no loose ends to pin it down. It is free to drift off the paper. This is the leaking pipe hypothesis. Gravity feels weak to us, not because it is weak, but because it is diluted. Most of its strength is leaking out of our universe and into the extra dimensions, into the bulk. This implies that right next to us, millimeters away in the 4th or 5th spatial dimension, there could be other sheets of paper, other brains or membranes. Massive objects in a parallel brain could be leaking gravity into ours. We might be feeling the ghostly pull of a galaxy that is physically adjacent to us in the bulk, but invisible to our eyes. We would perceive this only as a mysterious, invisible mass holding our galaxy together. We would call it dark matter. We are not just living in a locked room. We are living on a thin wall, and we can hear the footsteps of giants on the other side. If the existence of extra dimensions isn't dizzying enough, the shape of those dimensions turns the multiverse into a place of ultimate chaos. These 6 or 7 extra dimensions are not just empty space. They are folded into intricate microscopic knots called Calabi-Yau manifolds. And this is where the detective story turns into a horror story. The shape of the knot determines the vibration of the strings. The vibration of the strings determines the properties of the particles. One vibration makes an electron, another makes a photon. The geometry of the extra dimensions dictates the laws of physics themselves. If you fold the dimensions one way, you get a universe, like ours, stable atoms, starry nights, chemistry, life. But if you fold them another way, you get a universe with no gravity, or a universe where electrons are as heavy as bowling balls, or a universe where the strong nuclear force is too weak to hold atoms together and matter dissolves into radioactive dust instantly. Here is the problem. The math of string theory allows for an estimated 10^500 different ways to fold these dimensions. This collection of possibilities is called the string landscape. It is a map of every possible reality. And in this landscape, our life-sustaining universe is a statistical miracle. Most of the 10^500 universes are dead on arrival. They are barren wastelands, where stars cannot ignite, or violent hellscapes, where space rips itself apart in nanoseconds. We are not the chosen ones. We are simply the winners of a cosmic lottery, the anthropic principle in action. We are here to ask the question only because we happen to wake up in one of the few rare bubbles where biology is possible. This transforms the multiverse from a garden of life into a graveyard of prototypes. We are surrounded by an ocean of broken drafts, failed experiments, and abortive realities. But the most frightening part isn't that there are other universes. It's that the mechanism that creates them might not be finished. The string landscape isn't just a map of what could exist. It is a map of potential energy. And looking at our position on that map reveals a terrifying secret. We are not standing on solid ground. We are standing on a trapdoor. And that trapdoor could open at any second. We have explored the multiverse as a cosmic puzzle, a quantum shadow, and a hidden structure. But there is one final perspective we must confront. Our reality might be far more fragile than we believe. This instability stems from the very foundation of our existence, the Higgs field, often called the God particle field. This is the invisible energy grid that permeates the entire universe. It is the reason electrons and quarks have mass. Without it, you, the Earth, and the stars would disperse into light-speed dust. We exist because the Higgs field is stable, or at least we thought it was. In 2012, the Large Hadron Collider found the Higgs boson. It was a triumph for science, but the data it returned contained a hidden nightmare. When physicists measured the mass of the Higgs boson weighing in at 125 GeV and compared it with the top quark at 173 GeV, the numbers placed our universe in a terrifying category, metastable. Think of a ball resting in a valley. If it is at the very bottom, it is stable. It cannot fall further. This is a true vacuum. But our universe appears to be a ball resting on a narrow ledge high up on the cliffside. We are not at the bottom. We are in a false vacuum. We are safe for now, but we are precarious. At any moment, a quantum fluctuation could occur. A tiny region of space could tunnel through the energy barrier and drop to the lower stable state, the true vacuum. This event is called vacuum decay. If this happens, a bubble of true vacuum would nucleate somewhere in the cosmos. Inside this bubble, the laws of physics would be rewritten. The constants of nature would change. Atoms would not hold together. Chemistry would become impossible. And here is the horror. The bubble expands at the speed of light. Because it travels at the cosmic speed limit, no warning signal can ever outrun it. You could be looking at the sky admiring the stars, and the bubble could be 1 meter away from your retina, and you would not see it. When the wall hits, you don't die. You don't explode. You simply cease to be biological matter. Your atoms are instantly unbound and repurposed into the new lower energy physics of the dark universe inside the bubble. The Earth, the Sun, the galaxy, all incinerated, not by fire, but by a software update to reality itself. This might have already happened 1 billion light years away. The wall of deletion could be racing toward us right now, devouring galaxies in silence, and we will never know until the moment we vanish. In a multiverse of infinite possibilities, vacuum decay is not just a theory, it is an inevitability. If the physical instability of vacuum decay isn't unsettling enough, the statistical logic of the multiverse delivers a final existential vertigo. We often find comfort in the idea of parallel worlds. We like to imagine that somewhere a version of us made the right choice. We use the multiverse to escape the regret of our singular lives. But if we follow the logic of entropy and infinity to their absolute limit, we arrive at a conclusion that dissolves reality altogether. Deep in the far future, the universe will enter the dark era. Stars will burn out. Black holes will evaporate. The cosmos will become a vast empty void of random particles in thermal equilibrium. This is the heat death. But in an infinite timeline, dead does not mean still. Quantum mechanics says that random fluctuations will always happen. Particles will bump into each other. Given infinite time, eventually, a random fluctuation will assemble a hydrogen atom. Given more time, it might assemble a star. But statistically, in terms of energy and probability, it is far cheaper for the universe to create a small, complex object than a massive, complex universe. It is exponentially more likely for a random fluctuation to assemble a single, fully functioning human brain, complete with false memories of a past that never happened, than it is to create a Big Bang. This is the Boltzmann brain paradox. If the universe is truly infinite and eternal, then the vast majority of conscious observers are not biological beings evolved on planets. They are lonely, hallucinating brains popping into existence in the void, living for a few seconds, and then dissolving back into chaos. So ask yourself, why are you sure you are a biological human? You have memories of your childhood, of waking up this morning, of clicking on this video, but a Boltzmann brain would have those exact same memories implanted by chance. The logic of the multiverse suggests that it is statistically more probable that you are a momentary hallucination in the deep freeze of eternity than a real person reading a real script. The multiverse doesn't just promise that other versions of you exist. It threatens the possibility that this version of you, the one you think is real, is the fake one. We have explored the quantum shadows within the atom and traced the hidden structures of gravity itself. From the cold spot to the Higgs mass, the evidence points to a reality far stranger than a single universe. But this perspective brings a profound realization. The multiverse solves physics' greatest riddles by suggesting we are improbable survivors in a vast cosmic lottery. Yet it challenges our sense of singularity. If infinite versions of you exist, then every triumph and every failure plays out across the expanse of reality. In a landscape of infinite possibility, choice becomes a mechanism of branching. This is the paradox of infinity. When every outcome is true somewhere, we must ask what gives value to this specific timeline. Section 3.2, The Meaning of Now. So why does the concept of the multiverse captivate us so deeply? Perhaps we are not just seeking science, but an answer to our regrets. It suggests that somewhere you made the different choice. It is a possibility that soothes the limits of a singular life. But physics offers no easy comfort. Here is the reality. It does not matter if a billion other versions of you are living different lives. They cannot help you. They cannot feel the ground beneath your feet. To them, you are the shadow in the probability wave. The multiverse does not make this life meaningless. It makes it radically specific. Out of the quantum haze and the chaos of eternal inflation, this reality is the one that's solidified around you. You are the anchor of this specific now. Whether we are alone or crowded in a room of invisible mirrors, the conclusion remains: live this life as if it is the only one that counts, because for you, it is.